Okay, number 18 and 19. Recall that when you have tangent or cotangent graphs, your period is going to be pi over b instead of 2 pi over b. So let's see here. The period is pi over b, which is 1/3. And that's the same thing as pi multiplied by the reciprocal, giving you 3 pi. That means your increment is going to be 3 pi over 4. So in terms of shifts, I don't have any phase shifts, but I do have a up to. So I have a vertical shift of up to, and we'll deal with the asymptotes after we've graphed it. So here is my x and y axis. Remember, tangent is the graph where you're going to have 2 to the right and 2 to the left. That's the only one where you do that. Recall that we have a shift of up to, so I'm going to start at up to, and then my a value is 2, so I'm going to go up to 4, and then down to 0. Okay, so my period is 3 pi over, or period is 3 pi, increment is 3 pi over 4, so let me go ahead and add 3 pi over 4, add another 3 pi over 4, give me 6 pi over 4. Since we're centered at the origin here, I can just reflect it onto the other side. If you had a phase shift, you would have to subtract 3 pi over 4 to get your tick marks to the left-hand side. So again, notice here that this is my new xy axis because I have a shift of up to. So when you do positive tangent graphs, right, the end points, so to speak, are going to be your vertical asymptotes. And in the middle, we're going to have my x-intercept. And remember, positive tangent graph is increasing, positive cotangent graph is decreasing. So to make this increasing, we would have to go to that a value, and then here we would go to the negative a value. So again, you have to make sure it's lined up right here, and right here, make sure it's lined up. So I go concave up and concave down. For my asymptotes, notice we have it at negative 6 pi over 4, so x equals negative 6 pi over 4, and positive 6 pi over 4, or you could also reduce them down to plus or minus 3 pi over 2. Number 19, cotangent graph. The period is pi over b, so it's just pi. Note that your increment will be pi over 4. Asymptotes, we'll deal with that later. Shifts, we just have a phase shift of, if I set the whole thing equal to 0, it's going to be positive pi over 2, so it's right pi over 2. So let's go ahead and get started here. Anytime I have a phase shift, I like to start at the phase shift and 1, 2, 3, 4, fill in all the x values first, and then put the y-axis. So I'm adding my pi over 4. So pi over 2 is really 2 pi over 4. So if I add by pi over 4 each time, I get 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4. And I just reduced it there. And my y-axis means it's going to be over here somewhere. And I'm going an a value of positive 1/2 and negative 1/2. Notice that my xy axis really is now right here. Do you guys see that? This is like my new xy axis in terms of graphing. So on the ends, I'm going to have vertical asymptotes. So I can go ahead and write that the asymptotes are at positive pi over 2 and 3 pi over 2 for this one cycle. In the center, I have my intercept. It's positive cotangent, so it's going to be a decreasing graph. So right here, I'm going to have up. Right here, I'm going to go down. So concave up to the left and concave down to the right, giving me an overall decreasing graph. Number 20, find the value of each expression without using a calculator. Notice that when you're given the word arc, okay, so if you see like arc something or inverse sine something, that superscript there, you have to think of automatic restrictions. So remember, for inverse sine, it's between negative pi over 2 and pi over 2 for your angle answers. And for inverse cosine, it's between 0 and pi. For inverse tangent, it's between negative pi over 2 and positive pi over 2 as well. It's just exclusive of those n values, unlike in inverse sine. Another thing to remember is that inverse sine and inverse cosine, the ratio, right, will always be between negative 1 and 1. So if your ratio that's given to you falls outside of that, you have to say undefined. Let me just go over a couple of these. Like B, you have arc cosine of 4. That means if the ratio is 4, what is the angle within the restriction for cosine? Well, remember, inverse cosine and inverse sine have a restriction such that the ratio needs to be between -1 and 1, and 4 is outside of that, so the answer is undefined. Okay. Looking at C, arc sine of -√2/2. So what you do is you look at your unit circle here, and you think, where does my y value equal -√2/2? So you're really only looking at quadrant 1 and quadrant 4. So sine is going to be negative in quadrant 4. And in your unit circle, you're going to see your answer as 7 pi over 4, but you have to rewrite that as negative pi over 4. It's a coterminal angle. You're just going the negative rotation so that you stay within the restriction. Looking at E, you're looking at arc tangent of 1. That means you need a ratio of y over x of 1. So where do you, right, in here, right, we're looking here, in quadrants 1 and 4, get y over x of 1 overall, right? So that's going to be in quadrant 1. So if you look at y over x, the only place you're going to get the same value of 1 is going to be at pi over 4, right? Because you get √2/2, comma √2/2. If you put y over x, you're going to get positive 1. So the answer is positive pi over 4 for E. So 22, A, B, and C, I'll just go over them really quickly. Look at the inside. Because it's arc, this is a ratio. You're like, okay, for cosine, ratio is between -1 and 1, so that's good. Therefore, these undo each other, and you just get 1. Right here, you have the arc. Again, you look at the inside function first, and it's a sine, so that's not okay because it's beyond the -1 and 1 ratio, so it would be undefined. Okay. For C, again, you have arc tangent, but remember for tangent, you don't have a limit in terms of your ratio, right? It's -∞, infinity, so that's okay. These cancel out, they undo each other, and your answer is 15.2.